This FAT was prepared for the Linear and Switching Circuits unit of the Electronics Combined framework at Bournemouth University. It's a brief introduction to the important topic of CMOS circuits and links the linear devices and circuits we've been studying in this part of the unit to the large world of digital electronic design. As well as an introduction, we'll also look briefly at the advantages of CMOS, which have fueled the explosion of complex products based on cheap and powerful electronic integrated circuits. And finally, we'll look at how simple static logic functions can be built up in CMOS. Metal oxide MOS field effect transistors are made in depletion mode like junction FETs or enhancement mode as shown here, and with either N or P-type channels. We'll look at the N-type devices first. These have two highly doped N-type regions for the source and drain contacts and a block of P-type silicon. A layer of insulating silicon dioxide covers the channel between these contacts, and finally a metal or conducting polysilicon layer is formed over the channel as the gate contact. The transistor can operate as a linear amplifier or as a digital switch. If a positive voltage difference is applied between the drain and the source, no current can flow. However, if a positive voltage is applied to the gate, this will attract electrons from the highly doped source and drain regions along with minority carriers from the substrate. These will form a thin layer under the gate which is now acting as a charged up capacitor. This layer will form an N-type channel of electrons linking the electrons in the source and the drain. An electron current can then flow up from the source to the drain under the applied potential difference, forming a conventional current flow flowing from the drain down to the source. The size of the current is controlled by the available electrons in the channel, which is in turn determined by the voltage, the attracting field applied to the gate. So we have a linear device with an output drain current controlled by the input gate voltage. It's a field effect metal oxide transistor made from layers of metal, oxide and semiconductor, or MOSFET. As a digital device, it acts simply as a switch. With a low or negative voltage or digital zero on the gate, it won't conduct